So when we look at the pupillary frill, then the two physical things that it's going to pertain to will be what?
Is the stomach.
Okay, central nervous system and
stomach
lining. Not the intestines. The intestines will be further out in zone 2 there. But the two physical things that we'll be dealing with will be the central nervous system and the stomach lining.
Cover the embryological aspect.
I believe if you go back to the development of your physical vehicle, it's been a long time since I've looked at this, but to put it in a nutshell, I think when you're looking at the development of the physical vehicle, where obviously you start off as one cell, and then the cell divides and divides again and again, you get to a, without getting into too much detail here, you get into a certain phase where the cells begin to differentiate, and one particular type of cell develops and another particular type of cell develops. See, every cell in the body has all the, you have the same genetic material in all your cells, but the process of differentiation is where part of that genetic material is actually suppressed so that this cell eventually becomes a fingernail cell instead of a liver cell or what have you. Yes? Okay, well, I'm going to make it real easy here. I think what John's getting at here is basically if you go back far enough, back to where you're one cell, and you're starting to, the cells are starting to develop and all. You're starting to divide and grow as a being there in your mother's womb. There's a point there somewhere along the line where your cells have to start dividing up into different cell groups, into different types. Because ultimately some of your cells are going to become your liver and some are going to become your toenails and what have you. And there's some initial types of classifications of different cells. And basically what will eventually become your central nervous system and what will eventually become your stomach lining would be coming from the same basic type of initial cell group. That's what you're getting.
That is correct.
That's what and the name escapes me at this point. It's
the nails, the hair, the lining of the stomach, the lining of the intestines, and the skin.
And the skin. If you actually want to think about yourself in a functional sense, your skin and your entire digestive tract are just a direct extension. I mean, that's your dividing line between you and the world around you. I mean, if you think about it, you're a big donut or a big tube, right? From the mouth to the anus, there's just one continuous tube, and so in actuality, your stomach lining and your whole intestinal lining and the lining of your mouth and your throat and what have you, that's all really just a natural extension of your skin. And what John's getting at here is that the skin, the hair, the nails, the whole lining of the whole gut, as well as the central nervous system, all go back to the same initial type of cell. And again, I don't remember what the name of that is, but I don't know.
It doesn't matter.
But that's probably not important at this point.
Now, what happens when we see a person and we see what they're doing? How do we know when the central nervous system is beginning to heal? Go ahead, John.
Well, as far as what we see in the iris of the eye?
Yes.
Yes.
Or no, looking at the human body.
I suppose they'd start to have a much more rapid growth of the hair and the nails. That would be probably one good sign. Probably the skin would start to heal up, and I suppose the digestive system would start to work better as well, because you're going to be dealing with that whole group of things.
My son, Nare, stand up and turn around. What's happening to her hair? It's very quickly coming back to its natural color, isn't it?
Yeah.
What is this a sign of? It's a sign of regeneration, and when the hair is starting to turn back to its natural color, what is happening to the colon wall? What is happening to the stomach lining? What is happening to the skin? What's happening to the fingernails? Everything is beginning to regenerate. And all of this will be tied in directly to the pupillary ruff when we're looking at the iris of the eye. Question. Does this help you?
Yes.
Okay. Next slide. Lights, please.
Okay, if we want to look at it from a practical sense too, just a couple of things that bear mention here. If you want to work with the central nervous system, we go with the sensitive leaf T. I mean, it's a good idea for everybody, but some people need it more so than others. And if you want to work at the
Stop right here. Let's hand out the material on sensitive leaf T. You got it?
Yeah.
David, you pass it out to everybody, sir? Who does not have it? Who does not have the information on the sensitive leaf T?
I'm handing it out to everybody.
Neville doesn't have it yet, right up here. And we don't have the kitchen crew. The lights on, please, for one moment. Let's make sure everybody has it. Oi! In naturopathic school at the National College of Naturopathic Medicine in Kansas City, I had a doctor at that time who was my homeopathic instructor, and his name was Dr. Singh, S-I-N-G-H. He was a brilliant, brilliant teacher from India. Now, Dr. Singh had 3 doctorates. As a young man, he had the privilege of going to Tibet and studying directly under the physicians to the Dalai Lama, which was granted to him. Now I want you to listen very carefully. He told me that they had a record of teaching going back at least 6,000 years. And before that, the teaching of iridology went clear back to antiquity. Now, from a fundamentalist point of view, those who are involved with creation, they believe that the earth was only about 6,000 years old. But the Tibetan library at that time, according to his understanding, and according to 2 different men who spent much of their lives within the libraries in both Tibet and Dharamsala, which is in India today, that there is an unbroken record going back 12,500 years in the Tibetan libraries. And then a couple of breaks, and then going back 15,000 years, and then a few more breaks going back 20,000 years, and then a few more breaks going back 40,000 years. And yet you had civilization, according to the Aboriginals, going back around 40,000 years. Now, I have a record of a gentleman by the name of Joseph Jacquemin. You ever hear the name? He's a recluse. I don't even know where to write the guy. But he's traveled all over the world and has done research. And he has records of materials and things going back 3,500,000 years of recorded history. I think that what bothered me greatly, was that kind of rattled my crystals a bit, because I have been taught, and a lot of other people have been taught, of the creation theory. And then we go to India, and we find out it wasn't so. It went back much further than that. Then we go to Tibet, and we find out that they've got the records, and not just the legends, but the records that document the Indian legends. That go back way into antiquity. Folks, we're just little new birds learning how to sprout our wings. And what little knowledge we have is just a drop in the bucket. Let's not be too sure that we know it all. But Dr. Singh, I learned a lot from him. And the iridology, I didn't learn from him. But he said and told us that as a homeopathic physician, that I might add that when we were in Sri Lanka, we had the pleasure of talking to, upon occasion, I got to know him very well, the personal doctor to the head of the Indian government, and he was a homeopath. And homeopathy is used by nearly all of the Indian physicians and medical doctors. It is something well respected and no problem. And yet what astounds me is you have the physicians in the Western world, so to speak, your Canada, United States, Australia, New Zealand, where homeopathy is looked upon as a vile word. Okay? But here's where homeopathy reigns, is over in the concentrated population part of India, Pakistan, on into the much of the Muslim world there. Just something to consider. But Dr. Singh did understand the concept of iridology as taught by the physicians to the Dalai Lama. And we think in our Western world, and you find the history of it in Jensen's book, that it was discovered over in Hungary by Pensely and the broken leg of the owl and so on and the line. Well, it was rediscovered here in the Western world, but the ancient cultures, the ancient teachings goes way back into antiquity. And I just want you to know iridology is not a new science. It's as old as antiquity itself. And this is my understanding of it. The time is now 9 o'clock, folks. We're getting started on this beautiful subject. We're well into it now. You've got a lot of theory behind you that will give you an understanding of what we'll be covering tomorrow in depth. So try to leave this slide projector alone with the slides and so on. Will be the iris of the eye, but let's take it and see what part of the entire eye structure the iris is. Now the iris is roughly right in this area here. When you look into the eye, you have what they call that little black spot in the center of the iris, which is called the pupil. And this is this area looking down this way. You have what they call the cornea, which is the covering. And you have in this area here your anterior chamber, which is full of fluid. And then you look down through the pupil, down through this area in here, which we call the lens of the eye. And if you're looking into the lens of the eye, let me show you. You take your little, stand up, Doug, if you would. You take your little torch and you shine in this way, and up and down, and look all the way around the eye. And as you're looking in there, you will find that with the magnification, you'll have a reflection coming back. And that reflection that you're going to be picking up, that reflection will be a cloudiness of this particular lens. Now there are a number of you. Where's Ron? Is Ron here this morning? Okay, there are a number of you who have cloudy lenses, shall we say, which are on the verge of a cataract. And we're going to be talking about this a little bit later on as to exactly what we have to do to eliminate the cataract in the eye. But that cataract formation will cloud up this lens area here. You have going back through this whole area, into this area in here, you have what they call the optic nerve going on back this direction. Now, the optic nerve, roughly, is here. Now, as this particular part of the nervous system goes up this way, it goes right up into the lens, into the iris of the eye, where the only part of the central nervous system that you see will be the fibers in the eye. Where's Anita?
Right here.
Okay, would you get that first, on the other item there, would you get the first one ready? Not just yet. Get that ready to go. Okay? So what we have here is this portion of the iris of the eye is all tied into this area through here, coming right back into the optic nerve. Now another thing that's quite interesting, is the optic nerve moves back into the brain, but there are afferent fibers of the optic nerve which move into the pineal gland, and this is why we call the pineal gland a neuroendocrine transducer. And the pineal gland then will be controlled in its operation by environmental light. Now the melatonin, not melanin, which is your pigmentation, but the melatonin, which is a hormone from the pineal, will be secreted in response to environmental darkness, where when the eye is exposed to environmental light, that shuts off then the secretion of the melatonin. Now the melatonin shuts down the entire body system. We'll be explaining that in detail a little later, all right? But what we want to now discuss is where the position of the iris of the eye is. Now, can we move that a bit? As you're looking at the cross-section here, here is what we call the pigment rough. And this is when you're looking down through the pupil of the eye, down this way. This is the part that surrounds the pupil, and it's what we call the, thank you, it's what we call the part of the pigment rough right in here, but it goes and connects itself to this area down through here, which we will call the posterior epithelium, or what we call, here's the posterior epithelium here, and this is where you have the pigment layer of the iris of the eye. Now this pigment layer back in here is what you see diffuse through when light is shown on an eye, where you have no anterior chromatophores, or the brown pigmentation over the fibers. The light diffuses up through the fibers and you see a blue eye. But this is really a violet color back in here, a dark violet, almost black. It's almost like a black ink, you know, if you want to look at it, but it is really a violet color, and it shows up and diffuses up and makes the eye appear blue. If you have way here on the anterior portion of your iris, up in here, you'll have your brown chromatophores. Now the brown chromatophores will be the pigmentation factor, which will be the melanin pigmentation, indicating inherited stimulus response mechanisms which are inherited from our ancestors. And so that will be way up here in the very front portion of the eye. Now, if you notice, this is a Jensen slide. You'll have basically 4 levels. You have your acute level, which is your hyperactive level, where the fibers stand up. And then you'll have your subacute, chronic, and degenerative. So basically, there are 4 layers according to Jensen. What I have determined is that there are 7 layers of, instead of 4, and we'll get into that in what we call the fiber levels, which you'll have on one little sheet showing the 4 columns, where you have your 7 layers of your emotions, you'll have your 7 layers of fiber structures, and so on. And we'll go by the color of that in a few minutes. Or sometime today we'll get into that. Now the stroma, in this area here, the stroma, you'll find little blood vessels and nerves. And it'll show up way down in the stroma of the eye. Now, if you're seeing blood vessels, whether pink or red, in the iris of the eye, these will be appearing as follows. If I can find it. you're looking at anatomically is down in the stroma of the eye. This is take. Now, way down in the stroma of the eye, way down, the fibers are all supposedly on top of all this, okay? Now, we're looking here at several different parts of the eye. The blood vessels come into from the edge of the, what we call the, from the sclera, usually quite deep in the sclera, and they come into what we call then into the outer ring of the iris, which we call the limbus. But way down under the limbus is a circular blood vessel structure going all the way around the limbus, down deep. You cannot see that with the naked eye. I mean, you look at the eye, you can't see it. It's way down deep into what we call the stroma, okay? Now, the blood vessels move on in to a lesser circle, and the lesser circle will be right around what we call the autonomic nerve wreath. And the autonomic nerve wreath in this area, called the ANW, you'll have another smaller circle of blood vessels right around here. Now, normally, the blood vessels will be moving in from the sclera into this outer ring, and then from there in a fairly straight line in toward the smaller ring, or lesser ring. And then what we will have then is observing carefully what we call transversals, or abnormalities, or an aberrant positioning of the blood vessel. And wherever you have an aberrant positioning of a blood vessel, you're going to have a genetic weakness. And we're going to talk about this a little bit later on. It's going to be a little bit bothering to you, because you begin to realize how people are really quite more ill than they appear to be. Okay? But the fibers should go, the blood vessels should go straight. But many of the blood vessels go all over the place, and you have all kinds of blood vessels sticking up and out through the fiber structures. What we will see with the naked eye. Now, the blood vessels do not represent the central nervous system, but the fibers over the blood vessels in a normal eye, those will represent the central nervous system. And we're going to have a very close look at that. Doug, anything you want to say there, sir?
Just to reiterate it so that everybody's clear on this point, the iris is the only exposed portion of the central nervous system. So by extension, you see reflected in the iris direct neurological connection with every tissue in the body. That's important to understand, because it underlies the whole concept of iridology here.
And stomach meridian is unbelievably interesting how God made us. The stomach meridian, which starts right here, just below your eye, comes up and around and down. And the stomach meridian, which starts just below the eye, runs down the cheek, up around the top of the head, and right down through the center of the eye, which runs directly down to your stomach, which is the heart of your central nervous system, which is what John was talking about. In other words, there's a tremendous connection here, which has to do when you smile, when your eyes show a happy glint. It is all reflecting back to the central nervous system.
Explain the fibers as I put it up here.
Yeah, this is what we were talking about last night. John's drawn an iris up there. You'll have, right along here, you'll have the pupillary frill here. And of course, you'll have the pupil inside there. This structure right here, which will be kind of, ideally will be like a gently scalloped circle. I mean, it won't be perfectly round. It'll be kind of gently, you know what I mean by scallops? You know, going in and out slightly. That's going to be called the autonomic nervous reed. The autonomic nervous reed. We usually abbreviate the ANW. And then this structure out, you know, the outer margin of the iris is going to be called the limbus. The limbus. L-I-M-B-U-S. I believe Anita is going to be writing some of these terms down for everyone. And what John's going to draw now, the autonomic nerve reed is made up of iris fibers itself. But it's, of course, made up out of fibers that run in this direction. And later on in some of the eye slides, you'll see that the autonomic nerve root itself can be in actually many different depths. What John's drawing are the radial fibers in the iris here. And you'll see basically, we covered this last night briefly, but without a diagram. You'll see you've got this group of fibers that will start in at the pupillary frill. They'll start in at the pupillary frill and they'll move out to the autonomic nerve root and then circle back and join up with the pupillary frill again. So that's one group of iris fibers. This is not to scale here. I mean, the fibers are going to be smaller than we can really draw them here. And in practice, you're actually going to have fibers kind of bunched together, like where they're meeting out here on the autonomic nerve root. It'd be like a little ganglia, where you'll have a number of fibers that'll all kind of bunch in together and meet at these different points. And you'll have a second type or grouping of fiber that will start on the exterior of the eye at the limbus and move on into the center here and then work its way back on out to the to the limbus again. So you're going to go from the frill to the autonomic nerve root to back, and also from the limbus to the autonomic nerve root to back. Is that clear for everyone? Etc. Okay, the next thing that John's drawn right here, I'll wait till he finishes it. Okay, what John's showing right here is what we usually call a dent in the autonomic nerve root. And when we're dealing with the autonomic nerve root on a functional as well as a structural level, we're going to be considering the intestines, the large and small intestines. And when you're looking at the overall size and layout of the autonomic nerve root, this is going to tell you a lot about the structure and the function of the intestines. Is this where you want to be going right now, sir?
You're there.
Okay. He's steering. I'm just making sure I'm on the right same course here. You might want to take a quick look at your eye chart while we're looking at this, and you'll notice the way the large and small intestines are laid out there in the eye. Your small intestines, which will be relative to the large intestines, your small intestines are going to be where in the body, medial or lateral, relative to your large intestine, for the most part. They're all grouped there in the middle. So your small intestine is going to show up in the medial portion of the iris, towards the center, towards your nose. So if you look in the right eye, you're going to say roughly from about 1 down to 5, you're going to get your small intestine. In the left eye, from around 7 up to 11, you're going to get your small intestine. If you really want to see how it relates, the easiest thing to do is to just take your eye chart and stick it on your belly, because it really pretty much just lines everything up. You'll see down here you'll have the cecum down in this area where it should be. You'll have the ascending colon moving up the right side. You'll have the right half of the transverse colon going across the top of the right eye, and so forth on around. So it's a pretty sensible layout. There is some rhyme and reason to the way God put it together here. At any rate, once you start to learn, and we'll be seeing oodles of slides on the colon. So you'll have all that down as to where to look for different parts of the colon. But one of the things that we want to pay very careful attention to is the layout of the autonomic nerve root. Now, I guess what you could say an ideal autonomic nerve root would be roughly about a third of the way
cut it off.
I think I turned it off. It would be roughly about a third of the way out from the edge of the pupil to the limbus, and it would be a nice gently scalloped circle. If you're lucky and you look at a lot of eyeballs, you might actually find one like that. But most of the time, people's autonomic nerve wreaths are very uniquely their own, and you'll see all sorts of deviations in the structure of the autonomic nerve wreath. One of the major things that you want to look at with the autonomic nerve wreath is overall, is it a big one or a little one? I mean, does it have a tendency to be very, very large, like is it clear out to here in a lot of places? Or is it a very tight, close-in autonomic nerve wreath? And that's going to tell you a lot about the overall function of the person's intestines. If they have a very large autonomic nerve wreath, this is going to be what we call an atonic bowel. You're basically talking a very slow, sluggish type of situation where things take a long, transit time is pretty, fairly long. Excuse me? Basically, if you see an autonomic nerve wreath that's a big one, that's
Cover that, Doug.
okay, well, I wasn't sure where you wanted to go right now. You were drawing a dent in there, so.
Let me just talk about that for a moment. I want to talk about this particular stricture. It's called a dent or a stricture in the autonomic nerve wreath. Now, as I was drawing these little items here, and as Doug was explaining to you, the fiber moves from the pupillary rub out to the autonomic nerve wreath here and then back again. And from the limbus in toward the autonomic nerve wreath and back again. And Doug had mentioned how these are gathered together in little ganglia along here, which will correspond to what we call the parasympathetic and sympathetic nervous system in what we call the autonomic nervous system. Now, the interesting part is this. Whenever we have a stricture in what we call the autonomic nerve wreath, this stricture is mechanical on one aspect because it will be related to scar tissue in the intestinal area. And there is a Dr. Brown, and you'll find his book on the reading list. He has been first of all, he's a surgeon, and secondly, he's a parasitologist. And he made the statement that he has never found a stricture anywhere in the colon area without it being parasite related. Now, this parasitic related stricture then indicates that there will be scar tissue in this area. And if you look at this being the right eye, I turn this over from the original drawing. This will be in the cecum area, which, as Doug pointed out, will be roughly from 5 o'clock to 7 o'clock. And please look at your iris chart. You should be able to see that clearly. You got that? Yeah. Okay, so that will be in the cecum area. But from the iris point of view, you have then the fibers which represent the central nervous system. Listen carefully to my wording. The fibers are going to be hindered in their circulation of nerve supply to where it'll move out to the central nervous or the autonomic nervous system and back again in this area, and it's going to be all blocked. And as it's blocked off, then the corresponding area out in here will be blocked off. All right? And it's going to be hindered in the circulation of the nerve supply. And therefore, what you're going to find is that in this area, where you have a blocked off nerve supply, you will have in the absence of enzymes and minerals, you'll have the toxins in the body settling out in what we call the tissues of greatest weakness. And so you'll find pigmentation in this area, and or radii solaris, which is like a spoke line in a wheel, going out from the autonomic nerve wreath on out toward the limbus. Now, this area here is called a radii solaris, R-A-D-I-I-S-O-L-A-R-I-S. Now, the radii solaris will indicate a weakened condition in that part of the body that will be subject to viral material, bacterial infections, and parasites. It's like there's a red carpet laid out where if the person's going to have a problem with the bacterial infections like in the kidneys and bladder and so on, or in this area, it doesn't matter right now because that could be the kidney area because of the energy overlay, because you have a three-dimensional body on a two-dimensional picture here, and you are not going to be too sure as to what organ you're going to be looking at. Because if you look through the body and just look through it, you find that there will be, if you were to draw a line through the body, there might be several organs that you're going to intersect by that line. The same thing is going to be true in the iris of the eye. You're going to have several organs or structures of the body which will be in this represented by this one area. And so this is why, as Doug had pointed out, the more you know about iridology, the less you know, because you can't be too sure of what you see. All right? And that's because of that three-dimensional overlay on a two-dimensional iris. Now, of course, you can see down into the iris. But I don't know yet, and I don't know anybody who does know how to interpret that correctly. So what you do is you take an area and look at all aspects of that area and find out where the symptoms are. And then you take those symptoms, and that will pretty well tell you which organs we'll have to work with on the body electronics flow sheet, and what we have to do with any herbal or homeopathic or other support that would give that person in that particular area. But this stricture is a very important aspect. Now, one thing that you want to do when you're looking at the eye, especially the iris, you start with the pupil and kind of swing around in a little circle and take a look at what the pupil is, the shape of it. We'll get to that later. And then we look at the pupillary ruff and we look at the shape of that and the structure of that. We'll get to that later. And then we take a look at the area here, what we call the autonomic nerve reed, and we look at all of the little dents and bulges in it, or the strictures. And that tells us where the scar tissue is. Anita, would you do me a favor, please? Rotate that about 90 degrees counterclockwise, or clockwise, if you would. Just clockwise, 90 degrees. Good. Now, this is still a right eye. Now, let's say that, as Doug has pointed out, this will be the ascending colon portion of that. Now, if that is the ascending colon, we have a stricture in a new area. And the stricture is definitely going to be here. You look in that area and know that somewhere in the ascending colon, you're going to have a mass of scar tissue. So, in body electronics, you get the person down on the table, and you have the ascending colon through here, okay, in this area, and you take the person and find out in that ascending colon where the pain will be. And when you get the right area to dissolve that scar tissue, which may be considered to be an adhesion or scar tissue, anywhere in that area, here's what will happen. This stricture right here, when you dissolve that scar tissue, right before your eyes, this stricture will move out, and that thing will then be perfectly round if you get it the right spot. Now, you might have to hit 5 or 6 areas in that right midway up the ascending colon to get the right area to dissolve out those particular scar tissues. Then what will happen, as this moves out, then these fibers become like these, right along here, so to speak, and then that radii scleris, as you continue on with a full program of nutrients on the body level, not on the energy level, but on the physical body level, where you're dealing with your enzymes and minerals and so on, then that radii scleris will slowly disappear. It'll get shorter, and instead of being very deep, it'll get a little less deep until it's shallow, until it disappears entirely. And then this would represent on your iris chart the lung area, for example, maybe the lower lobe of the lung, and then that lower lobe of the lung where you're having a problem with continual begin to clear up until that stricture is gone. You follow me? So if you have a lung problem, you treat the lung problem all day, and it won't change. You have to go back here to the stricture that you see, and then back in here and dissolve that scar tissue and get that out of there. The Schweitzer formula will help immensely in dissolving the scar tissue. And then with the body electronics properly applied, that stricture disappears, and then this area here in the lung area will clear up. Now you'll notice this being the right eye, at roughly 9 o'clock, you'll have the heart area in there also. And Jensen will agree to that. Where you'll have, in the left eye, you'll have it over here at roughly 3 o'clock, from 2:30 to 3 o'clock. In the left eye, in your chart, you'll see it in the left eye where the heart is, but you'll see the heart also in the right eye, roughly at about 9 o'clock. And just opposite from where Jensen says it is in the other eye. So it's in both eyes. And so if this is going to be the lung, we know that the lung will be tied in to the heart area by reaction, reflex, shall we say.